First, we define a max heap data structure, and then we initialize an instance of a given heap size. So the purpose of the heap size parameter is to set the maximum size of the heap that we want to allow, which determines the size of the underlying array which we will use to store the heap elements. And then we set the maximum size of the heap to the given heap size parameter. So when we add an element to it, this value will be used to determine if this heap is full. We create an array self-max heap to store the elements of the max heap. The size of the array is set to heap size plus 1, where the heap size is the maximum number of the elements which are allowed in the heap. The reason for us adding 1 to the heap size is to account the fact that the root node of the heap is stored at index 1, not index 0. So by doing this, the arithmetic for calculating the indices of the parent and the child nodes in this array-based binary tree representation of the heap becomes simpler. It provides a lot of benefits. First is for parent node index calculation. For a node at index I, its parent node is at the index I floor divided by 2. So this calculation works only if the root node is at index 1. Since the parent node of the root node is undefined, so when I is 1, I floor divided by 2 is 0, which indicates the root node has no parent. And the second is for the left child node index calculation, because for a node at index I, its left child node is at index I multiplied by 2. This calculation is simpler when the root node is at index 1, because the left child of the root node is at index 2, which is 1 multiplied by 2. And the third is the right child node index calculation, because for a node at index I, its right child node is at the index I multiplied by 2 plus 1. This calculation is also simpler when the root node is at index 1, because the right child node of the root node is at index 3, which is 1 multiplied by 2 plus 1. By storing the root node at index 1, these arithmetic operations for parent and child nodes are straightforward and easy to remember, right? So this makes the implementation of the heap operation more efficient and easy to understand, which is especially useful when we try to maintain the max heap property and when we add or remove elements from the heap. We initialize the real size variable to 0. The real size variable is used to keep track of the actual number of the elements which is currently stored in the max heap. So the real size variable is different from the heap size variable. The heap size denotes that the maximum number of the elements that can be stored in the max heap. The size of the underlying array, which is real size, represents the current number of the elements actually stored in the max heap. So the real size variable is updated whenever the elements are added or removed from the max heap. It is also used in the variable heap operation, like adding, removing, or checking the size of the heap to ensure that the max heap property is maintained and the heap does not exceed its maximum size. The size method returns the current number of the elements in the heap. It does so by returning the value of the instance variable self-real size. The self-real size is updated whenever an element is added or removed from the heap by using the add or the pop methods. Thus, the value of self-real size always reflects the current number of the elements in the heap, which making it a convenient way to determine the size of the heap. And then we define double_string self method and return a string representation of the current state of the heap. So this method is called automatically when we attempt to print a heap object or when we use a string function to convert it into a string. And inside this method, we slice the underlying array self heap from the index 1, which is inclusive, to the self.real size plus 1, which is exclusive. That means it will contain until self.real size. So this slice will contain all of the elements in the heap, right? As the root node is stored at the index 1, and the self.real size indicates the number of elements in this heap. So just by using this string function, this slice is converted into a string representation of the list of elements in the heap. The string is then returned by the double_string self method. And then we define a section that will only be executed when the script is run directly, so as opposed to being imported as a module in other script. And then we create a heap object with a maximum size of 5 elements.